Section 3.5 is pretty quick and easy, especially in comparison to 3.4, that marginal analysis we just did. Now we're switching gears to higher order derivatives. A higher order derivative is when differentiation goes beyond that first derivative, f prime. But it's not too hard to do. Higher order derivatives are also called multiple derivatives. And you are just going to take the derivative of your derivative in order to find an answer. So if you want the second derivative, you're going to take the derivative of the first derivative. If you want a 10th derivative, you're going to take the derivative of your 9th derivative. So the hardest part about this is getting used to some new notation. So we've already done first derivatives. So let's say the original function is f of x. The first derivative of that is going to be called f prime of x. We've done that before. Now we're going to also take second derivatives, and we're going to call those f double prime of x. A third derivative is going to have f triple prime of x. So f with 3 tallies. Anything beyond the third derivative, if you want an nth derivative, you would just do f with a superscript n up there. So if you did f and you have a superscript 9 and then an x, you want to know that means the 9th derivative, which is crazy. We probably would never go that high. Same thing with y's. If you start with a y, your first derivative is called y prime. Then your second derivative is called y double prime. Your third derivative is y triple prime. And anything beyond 3, we usually don't write the tallies up there anymore. We would do y with a superscript and with the number of derivatives you're supposed to take. The last notation is the hardest, and I'm only doing it because we're going to learn some implicit differentiation this exam. So I'm going to write this new notation, and we've used it before, but not with higher order derivatives, obviously. So derivative of y can also be written dy dx. That means derivative of y with respect to x. And the second derivative would be written d squared y. It means the second derivative of y with respect to x twice, dx squared. So same thing with the third derivative, d cubed, derivative cubed of y over dx cubed means with respect to x 3 times. And with any derivative, we would have d to the n y over dx to the n. Just some crazy notation, which we'll use a bit later when we do implicit differentiation. So the hardest part is remembering to label your functions. Finding the derivatives is not too bad. So let's take the 6th derivative of this function here. So we're going to take the 6th derivative. So we're going to start by taking the first derivative, which is 7x to the 6th plus 12x to the 5th plus 6x minus 4. Taking that first derivative like we've done before. Now we're going to take our second derivative by taking the derivative of our first derivative. So now I'm looking to this line here, and I'm going to take the derivative of it. So derivative of 7x to the 6th, 7 times 6 is 42, x to the 5th. 12 times 5 is going to be 60, x to the 4th. Derivative of 6x is 6, and derivative of minus 4 is 0. So there's my second derivative. I'm not done yet because I'm asked to go all the way to the 6th derivative, so I'm going to do y triple prime, the third derivative. 42 times 5 is 210, x to the 4th. 60 times 4 is 240, x cubed. Derivative of 6 is 0. So we're done with our third derivative. And now I'm going to write it as y superscript 4 instead of writing 4 tallies. So I'm going to do 210 times 4 is 840, x cubed, and of course you can use a calculator if you need one, plus 240 times 3 is 720, x squared, And now I'm ready for my fifth derivative. I'm almost there. Got to remember to label it. And to find the fifth derivative, you take the derivative of your fourth derivative. So 840 times 3 is 2520. I'm going to have x squared now when I subtract 1. Plus 720 times 2 is 1440. And I just have x to the first as my new power. Last one. Trying to take the sixth derivative here. 2520 times 2 is 5040. And now I have x to the first there. And derivative of 1440x is 1440. So a decent amount of work, but I wouldn't say it's hard work. And you just want to make sure you label your derivatives for full credit. And we're done with our sixth derivative.